In question 1, we have to express 3x squared minus 12x plus c in the form a into x plus b squared plus c, where a, b, c are constants. So what we can do is we can write this equation, which is the expression, which is 3x squared minus 12x plus c. And to convert it to this form, we can first expand it. So this will become x squared plus 2bx plus b squared plus c. Now expanding this will become ax squared plus 2abx plus ab squared plus c, and that is equals to 3x squared minus 12x plus 7. Now comparing the coefficients on the left and the right hand side. So on the left hand side, the x squared coefficient is 3, and on the right hand side it is a. So we can write that a will be equals to 3. Comparing the coefficients of x on the left and the right hand side, so it is 2ab on the right hand side and minus 12 on the right hand side. So that will become 2ab is equals to minus 12. Now as a is 3, so this will become 6b equals to minus 12, and b will be equals to minus 2. And finally, comparing the constant term, which is 7 on the right hand side, and on the right hand side it is ab squared plus c. On the left hand side it is 7, so ab squared plus c will be equals to 7. A is 3 and b is minus 2, so this will become 3 into minus 2 whole squared plus c is equals to 7. So 2 squared will become 4 times 3, which is 12. So c plus 12 equals to 7, and c will be equals to minus 5. Once we have the values of a, b, and c, we can write the expression as 3 into x, and the value of b is minus 2. So this will become minus 2 whole squared, and the value of c is minus 5. So the final expression will be 3 into x minus 2 whole squared minus 5. In question 2, we have to find the coefficient of 1 upon x in the expansion of x minus 2 upon x to the power 5. Now, the expansion formula for an expression of the form a minus b to the power n is given as a to the power n minus nc1 a to the power n minus 1 b power 1 plus nc2 a to the power n minus 2 b power 2, then a minus nc3 a to the power n minus 3 b to the power 3. Now we can try and figure out for which value, for which expression we'll get a coefficient of 1 upon x. So this means that we need the power of x in the denominator 1 more than in the numerator. Now, either we can try and guess which one of these it will be, or we can figure it out. So we know that the expression is x minus 2 upon x to the power 5. So we do not know which value to take, 5c1, 5c2, or 5c3. So we can write this as 5cr. A is x, so this will become x to the power 5 minus r, and in b, the power of x is minus 1. So this will be minus 1 to the power r. And we need it as 1 upon x, or x to the power minus 1. Now, as we just have to find the coefficient of x, so we can compare the powers of x. So this will become x to the power 5 minus r, and this will also be minus r is equals to x to the power minus 1. Now, comparing the power, this will become 5 minus 2r equals to minus 1. 2r will be equals to 5 plus 1, which is equals to 6. So r will be equals to 6 divided by 2, which is equals to 3. Now, once we have r equals to 3, we can write this as 5c3. So we'll write 5c3 into a, which is x to the power 5 minus 3, into b, which is minus 2 upon x to the power. So 2 upon x to the power, this will become to the power 3. Now, if we substitute 5c3 in the calculator, so 5c3 is equals to 10. So we'll get, so this will be 10 into x to the power 2. And minus 2 whole cube will become a minus 8 upon x cube. So x square and x cube will cancel, and we can see that we'll have a term in 1 upon x. And 10 times minus 8 will become minus 80 upon x. So the coefficient for 1 upon x will be equals to minus 80. In question 3, the common ratio of a geometric progression is 0.99. We have to express the sum of the first 100 terms as a percentage of the sum to infinity, giving your answer correct to two significant figures. Now, the common ratio is 0.99. We know that the formula for sum to infinity is given by a divided by 1 minus r. So we can write this as a divided by 1 minus 0.99. So A divided by 1 minus 0.99, that will be equals to 100A. And now to find the sum for the 100 terms, we know that the sum for n terms is given by the formula A into 1 minus r to the power n divided by 1 minus r. So we can write this as A into 1 minus 0.99 to the power 100 divided by 1 minus 0.99. Now, if we substitute this in the calculator, we'll get 63. So that will be equal to 63.3967A. Or we can write it as 63.4A. So this will be equal to 63.4A. Now it says we have to express the sum of the 100 terms as a percentage of the sum to infinity. So we can write this as 63.39, or this was 63.4. So to find it as a percentage, we can write it as, so the sum of 100 terms was 63.4A. The sum to infinity was 100A, and multiplying it by 100. So A and A will cancel, 100 and 100 will cancel out. This will become 63.4%. Now, as we had to give our answer correct to two significant figures, so we can write the final answer will be equal to 63%. In question 4, a curve with equation y equals to f of x passes through the point a 3, 1 and crosses the y-axis at b. It is given that f dash of x is equals to 3x minus 1 to the power minus 1 upon 3. We have to find the y-coordinate of b. Now, we know that as it is crossing the y-axis, the x-coordinate will be 0. So in the first step, we'll have to find the equation of the curve. So we know that the derivative of f of x is 3x minus 1 to the power minus 1 upon 3. To find the expression for f of x, we'll integrate the expression for f dash of x. So that will be f of x will be equals to 3x minus 1. We'll increase the power by 1, so that will become plus 1 upon, so that is a 1 upon 3 up here. So this will be minus 1 upon 3. And when we increase the power of minus 1 upon 3 by 1, so minus 1 upon 3 plus 1, that will be equals to minus 1 plus 3 upon 3, which is equals to 2 upon 3. So this power will become now 2 upon 3, and we'll divide it by the new power, which is 2 upon 3. And also multiplied with the derivative of 3x minus 1, which is 3. So this will cancel out, and we'll add a plus c. So f of x will be equals to 1 upon 2 into 3x minus 1 to the power 2 upon 3 plus c. Now it says that it passes through the point A, which is 3 and 1, which means when we substitute x equals to 3, it will be equals to 1. So we can write it as 1 is equals to 1 upon 2 into 3 into 3 minus 1 to the power 2 upon 3 plus c. So this will become 9 minus 1, 8. So this will have 1 upon 2 into 8 to the power 2 upon 3 plus c equals to 1. A to the power 2 upon 3, so that will be 8 cube root is 2, 2 square is 4, and 4 divided by 2 will become a 2, and that will be 1 is equals to 2 plus c. So the value of c will be equals to minus 1. So an expression for f of x will be equals to 1 upon 2 into 3x minus 1 to the power 2 upon 3 minus 1. Now at point B, we know that it crosses the y-axis, so the coordinates of point B will be 0, y. So we'll substitute x equals to 0. So f of x will be equals to 1 upon 2 into 3 into 0, which will be 0 minus 1 to the power 2 upon 3 minus 1. So minus 1 to the power 2 upon 3 will be a minus 1. Or that will become a plus 1, as cube root of minus 1 will be minus 1, and minus 1 whole squared will become a 1. So we'll get 1 upon 2 minus 1, which is equals to minus 1 upon 2. So the y coordinate at the point B, so that will be equals to, so the B will have coordinate 0, minus 1 upon 2, or we can just leave the answer as y is equals to minus 1 upon 2. Question 5, the diagram shows a triangle OAB in which angle OAB equals to 90 and OA equals to 5. The arc AC is part of a circle with center O. The arc has length 6 and it meets OB at C. We have to find the area of the shaded region. Now to find the area of the shaded region, we'll have to find the area of the triangle OAB and subtract the area of the sector OAC. So in the first step, we'll have to find this angle. And as we know, the arc length is given by the formula S equals to R theta. The arc length is 6 and the radius is 5. So theta will be equal to 6 upon 5, which is equals to 1.2 radians. Now to find the area of the triangle, first we can find this length AB and then apply half base into height. So as it is opposite to this angle AOC, we can write tan of 1.2 will be is equals to opposite, which is AB upon 5. So AB will be equals to 5 multiplied by tan of 1.2. Substituting this in the calculator, the length of AB will be equals to 12.86 centimeters. Now, once we have the length of AB, we can find the area of triangle. So the area of triangle AOB will be equals to half into the base. We can take the base as 5 and the height, which will be 12.86. Substituting this in the calculator, the area of the triangle will be equal to 32.15 centimeters squared. Now finding the area of the sector. So the area of a sector is given by the formula half r squared theta. The radius for the sector is 5. So this will be half into 5 squared and the angle was 1.2 radians. So 25 multiplied by 1.2 and then dividing it by 2, that will be equals to 15 centimeters squared. And then finally the area of the shaded region will be equals to, so the shaded region is equals to the area of the triangle, which is 32.15 minus 15 centimeters squared, which will be equals to 17.15 centimeters squared. And as we have to give our answer to 3 significant figures, so the final answer will be 17.2 centimeters squared. In question 6, the coordinates of points A and B are given as 3k minus 1 minus 3k minus 1 and k plus 3 for A and k plus 3, 3k plus 5 for B. In part 1, we have to find and simplify the gradient of AB and show that it is independent of k. So the formula for gradient is y2 minus y1. So we can take y2 as 3k plus 5 and minus k plus 3, which is y1, and divided by x2 minus x1. So x2 will be k plus 3 and we'll subtract it from minus 3k minus 1. So first opening the bracket, that will become 3k plus 5 minus k minus 3 and we'll divide it by k plus 3. This will become a plus 3k and this will become a minus minus plus 1. Now simplifying the numerator, that will become in the numerator that will be 3k minus k, which is 2k, and 5 minus 3 is a plus 2. In the denominator, k plus 3k will become a 4k and that will become 3 plus 1 equals to 4. Now taking k common, so we can take 2k common in the numerator, that will become, so that will become k plus 1, or that will become, so if we take, we cannot take k common, so we'll just can take 2 common over here and that will be equals to, so 2 will be equals to k plus 1 and in the denominator taking 4 common, that will be equals to k plus 1. So k plus 1 will cancel out. So the gradient of AB will be equals to 2 upon 4 or 1 upon 2. In part 2, it says find and simplify the equation of the perpendicular bisector of AB. Now to find the perpendicular bisector of AB, so let's say this is the line of AB. We need the gradient and the perpendicular bisector will pass through the midpoint of AB. And we also need the gradient to first find the equation. So the gradient, as the gradient of AB was 1 upon 2, the gradient of the perpendicular bisector will be equals to -2. So we have the gradient of AB, the midpoint. So in the first step, we can find the midpoint of AB. That is x1 plus x2 upon 2. So that the x1 value is minus 3k minus 1. And we'll add it to k plus 3 divided by 2. And y1 is k plus 3. So this will become k plus 3. And that will divide by, that will add with 3k plus 5, which is y2 upon 2. So simplifying this, minus 3k plus k will become a minus 2k. Minus 1 plus 3 is a plus 2 upon 2, comma. So k plus 3k will be a 4k and 5 plus 3 is 8 divided by 2. So dividing it by 2, minus 2k upon 2 is a minus k and 2 upon 2 is 1. So this will become minus k plus 1 and this will become 2k plus 4. So once we have the coordinates of the midpoint and we also have the gradient, which is -2. So the equation is given by the formula y minus y1 is equals to m into x minus x1. So this will be y minus y1 is 2k plus 4 is equals to m, which is -2 into x minus, and x1 is minus k plus 1. Now expanding this, we'll get y minus 2k minus 4 is equals to -2, and this will become x plus k, and this will be up -1. So expanding this bracket now, we'll get minus 2x minus 2k plus 2. Now minus 2k and minus 2k, they will cancel out as they have the same sign. So when we bring them on one side, this will become minus 2k plus 2k, so that they will cancel out. So the final equation will be y is equals to minus 2x. This is a plus 2, and the 4 will come on the right hand side and become plus 4. So the equation will be y is equals to minus 2x plus 6 for the equation of the perpendicular bisector. In 7a part 1, we have to express tan square minus 1 upon tan square plus 1 in the form a sine squared plus b, where a and b are constants. So to convert it to sine squared form, we know that the tan is equals to sine upon cos. So as tan theta is sine theta upon cos theta, so tan square will be sine squared upon cos squared. So this will become sine squared upon cos squared minus 1. And this will divide by tan squared plus 1. So this will be written as sine squared upon cos squared plus 1. Now taking the LCM in the numerator, we'll get sine squared minus cos squared upon cos squared. And the denominator will become, so this will become sine squared plus cos squared upon cos squared. So cos squared and cos squared, as they're in the denominator, they will cancel out. This sine squared plus 1. So sine squared plus cos squared is equals to 1. So we'll get sine squared minus cos squared in the numerator and dividing it, and that will be dividing by 1. Now, as we have to bring our equation in the complete sine squared form, so cos squared is given as 1 minus sine squared. So this will become 1 minus sine squared. Opening the bracket, we'll get sine squared minus 1 plus sine squared. So the final answer will be sine squared plus sine squared, which is 2 sine squared theta minus 1. So we have to bring it into the form a sine squared plus b. So a will be 2 and b will be minus 1. In part 2, it says, hence or otherwise show all necessary working to solve the equation for minus 90 to 0. And the equation is the same, tan squared minus 1 upon tan squared plus 1 equals to 1 upon 4. Now we know that this can be written as 2 sine squared minus 1, and we can write it equals to 1 upon 4. Now taking 1 on the right hand side, that will become 2 sine squared is equals to 1 upon 4 plus 1. So 2 sine squared will be equals to 5 upon 4, and 2 will divide on the right hand side. So we can write it as sine squared theta will be equals to 5 upon 8. Now to find theta, we'll have to find the inverse of, so this will become sine inverse, and this will take the square root of 5 upon 8. So if we take shift sine inverse and the square root, so we'll first take the square root of 5 and it will divide by 8. So, and we have to make sure that the calculator is in the degree mode. So converting it to the degree mode, this will be equals to, so theta will be equals to 52.238 degrees. Now, as the domain or the theta values are from 0 to 90, so if we make this in the quadrant, so this is the first, second, third, and the fourth. So the first, second, third, fourth. Now, due to the square root, we can also take this in the negative quadrants of sine, which is the fourth quadrant. And as it is a negative angle, so making 52.38 in the negative quadrant of sine, this is 52.38 degrees over here. And as it is from 0 till minus 90, so in this case, we'll take the angle clockwise. So this angle theta will be equals to minus 52.3. So this is not 38, this is 23. Just a small correction over here. That will be equals to 0.23 degrees. And the final answer will be minus 52.23, as the domain is from 0 till minus 90. So this will become minus 52.2 degrees. This will be the only value of theta. In part B, it says find the diagram shows the graphs of y equals to sine x and y equals to 2 cos x. For my x minus pi to pi, the graphs intersect at the point A and B. We have to find the x coordinate of A. Now, as the graphs are intersecting at the point A, we can write sine x will be is equals to 2 cos x. Taking cos on the left-hand side, that will become sine x upon cos x is equals to 2. So this will be equals to tan x and tan x will be equals to 2. So x will be equals to tan inverse of 2. And as the x value is from pi minus pi to pi, so we'll have to convert our calculator to the radian mode. Now taking tan inverse of 2, that will be equals to 1.107. So we'll get 1.1071 radians. And as we know that A will have a positive x coordinate, so we will not have to find the negative value. So the x coordinate of A will be equals to 1.107 or to 3 significant figures as 1.11 radians. In part 2, it says find the y coordinate of B. Now to find the y coordinate, we'll first find the x coordinate. Now to find the x coordinate, and we know that the x coordinate is a negative over here and the y coordinate will also be negative at the point B. So to find the negative x coordinate, and we know it is from minus pi till pi, so we'll make this 1.11 radians in the third quadrant, which is the positive quadrant for tan. So this is A, C, T, S. Now, as we have to find the negative angle, so we'll take the angle clockwise from the positive x-axis. So this angle will become pi minus 1.11. So taking pi, so pi minus 1.11, that is equals to 2.0315. So this angle will be equals to, we'll take it as minus 2.0315, or we can write it as pi minus 1.11, which is equals to minus 2.0315 radians. Now, as this is the x coordinate or the x value, now we know that the equation of the curve was y equals to sine x or y equals to 2 cos x. We can take either of these two equations. So taking y equals to the equation sine x, we know that the x value is minus 2.0315. So y will be equals to sine of minus 2.0315. Now substituting this in the calculator, we'll get, so sine of minus 2.0315, that will be equals to minus 0.8957 radians. And to 3 significant figures, this will be minus 0.896 radians. It is a y value, so this will just be y equals to minus 0.896. Question 8, the tangent to the curve y equals to x cube minus 9x squared plus 24x minus 12 at a point A is parallel to the line y equals to 2 minus 3x. We have to find the equation of the tangent at A. Now, we know that this line y equals to 2 minus 3x, we can write it as minus 3x plus 2. The gradient of this line we can see is minus 3. So if a line is parallel to this y equals to 2 minus 3x line, it means it will also have a gradient equals to minus 3. So to find the gradient of the tangent of the curve, we know that the curve has equation y equals to x cubed minus 9x squared plus 24x minus 12. To find the gradient of the tangent, we'll find the dy by dx. So that is equals to 3x squared minus 18x plus 24. And we know that this gradient is equals to minus 3 as a tangent is parallel to this line. So we can write it equals to minus 3 over here. And this will be 3x squared minus 18x plus 24. Taking 3 on the right hand side, we'll get 0 is equals to 3x squared minus 18x, and 24 plus 3 will become a 27. Simplifying this, we'll get 3x. Okay, so we can divide this by 3, the whole equation. So that will become x squared minus 6x plus 9 equals to 0. Factorizing this, we'll get x minus 3, and this will be x minus 3 equals to 0. So the x coordinate will be equals to 3. Once we have the x coordinate of the tangent, we can find the y coordinate using the equation of the curve. So y will be is equals to So that will become 3 cube minus 9 into 3 squared plus 24 into 3 minus 12. So 3 cube is 27. This will become minus 9 into 9, which is 81. 24 times 3 will become 72 minus 12. So the y coordinate will be, substituting this in the calculator, we'll get 27 minus, this is 81 plus 72 minus 12, and that is equals to 6. So the y coordinate is 6. We have the x coordinate and the gradient is minus 3. So the equation of the tangent will be y minus y1, which is 6, is equals to m, which was minus 3, into x minus x1, which was equals to 3. Simplifying this, we'll get y equals to minus 3x plus 9 plus 6. So the equation of the tangent, we can finally write it as minus 3x plus 15. In part 2, it says the function f is defined by x cube, the function x cube minus 9x squared plus 24x minus 12 for x greater than k. We have to find the smallest value of k for f to be an increasing function. Now, for f to be an increasing function, the derivative of f dash of x must be greater than 0, the derivative of f of x. We know that the derivative was given by the expression 3x squared minus 18x plus, so 24x, differentiating that, that will become 24 as greater than 0. Now to factorize this, we can first divide the whole equation by 3 and write it as x squared minus 6x plus 8 greater than 0. And factorizing this, we'll get x minus 4 and x minus 2 greater than 0. So the two values of x are 4 and 2. And we know from the question that x has to be greater than k. Now the two values of x, we can plot them on a graph. This is 4 and this is 2 over here. Now we know that for the function to be an increasing function, x has to be less than 2, as it will be positive towards the left of 2 and towards the right of 4. So it has to be less than 2 and x has to be greater than 4. And as the question said that x has to be greater than a value k, so in this case, the answer will be x will be greater than 4, or the value of k will be equals to 4. In question 10, the one-to-one function f is defined by f of x equals to x minus 2 whole squared plus 2, where x is greater than equals to c. In part 1, we have to state the smallest possible value of c. Now, if it is a one-to-one function and we have the function f of x is x minus 2 whole squared plus 2, so if we plot this on the x and the y axis, the turning points are 2 and minus 2. So for it to be a one-to-one function, if this is a quadratic function like this over here, the turning point are at this coordinate, which is, so this coordinate is 2 and minus. So this is 2 and positive 2. Now, as x has to be greater than equals to c and it has to be a one-to-one function, so the smallest possible value of c will be equals to 2. So the value of c will be equals to 2. In parts 2 and 3, the value of c is 4. We have to find an expression for f inverse and state the domain of f inverse of 4. So we know that as the value of c is 4, so x will be greater than equals to 4. Now in the first step, to find the expression for f inverse, we know that f of x is equals to x minus 2 whole squared plus 2. Writing y in place of f of x, we'll get y equals to x minus 2 whole squared plus 2. Now exchanging the values of x and y, so we'll get x equals to y minus 2 whole squared plus 2. Taking 2 on the left hand side, we'll get y minus 2 whole squared equals to x minus 2. Taking the square root now on both the sides, so this will become y minus 2 will be equals to square root of x minus 2. And finally, taking 2 on the right hand side, that will become y equals to square root of x minus 2 plus 2. So the f inverse function can be written as square root of x minus 2 plus 2. Now we know that the domain of f of x is the range of f inverse of x, and the domain of f of x was x greater than equals to 4. Now for this function to be greater than equals to 4, we need this. So this is 2 and the square root value must be 2 at least. So for that, x will be equals to 6, or we can just solve it by x minus 2 plus 2, and it should be greater than or equals to 4. So taking 2 on the right hand side, that will be x minus 2 is greater than equals to 2. Whole squaring both the sides, we'll get, so x minus 2 will be equals to greater than equals to 4, or x will be greater than equals to 6. So for the domain of f inverse will be x should be greater than or equals to 6. In part 3, it says we have to solve the equation f of x equals to 51 and give our answer in the form a plus root b. Now, the function f of x was x minus 2 whole squared plus 2. Now, to find f of x, that means that in the function f, in place of x, we'll replace it with the whole function f of x, which is x minus 2 whole squared plus 2. So this will become x minus 2 whole squared plus 2 minus 2 over here, and this is whole squared plus 2. So 2 and 2 will cancel out, and we'll get x minus 2 whole squared, and that is also whole squared, so that will become a plus 2 power 4 plus 2 equals 2, and that is equals to 51. So taking 2 on the left hand side, that will become 49 is equals to x minus 2 to the power 4. So if we square root both the sides, we'll get, so this power 4 and this power root, which is 1 upon 2. So we'll get x minus 2 to the power 1 upon 2 will be equals to 7. And now taking the square root of 7, we'll get x minus 2 is equals to square root of 7. So the x value will be square root of 7 plus 2. Now, as the domain was x is greater than or equals to 6, which means we cannot take a negative value, the x value will be, x will be equals to square root of 7 plus 2. So the domain was x is greater than 4. So if we take the negative value for the square root, that will become less than 4. So the only value for x will be x equals to square root of 7 plus 2. In question 11, the diagram shows part of the curve y equals to x plus 1 whole squared plus x plus 1 minus to the power minus 1, and the line x equals to 1. The point A is a minimum point on the curve. In part 1, we have to show that the x coordinate of A satisfies the equation 2 into x plus 1 whole cube equals to 1, and then find the exact value of d squared y upon dx squared. Now, as it is a minimum point, so we'll have to first find the dy dx of the curve. So the dy dx will be is equals to, we'll multiply 2 with the coefficient. So this will become 2 into x plus 1. This will become a power 1. And we'll multiply with the derivative of x plus 1, which is 1. And over here, so minus 1 will multiply by plus 1. So this will become minus into x plus 1 to the power minus 2. And the derivative of x plus 1 is 1. So that will remain as it is. And as it is a minimum point, so dy dx will be equals to 0. So we can write this as 2 into x plus 1 minus 1 upon x plus 1 whole squared. Taking this on the left hand side, we'll get 1 upon x plus 1 whole squared is equals to 2 into x plus 1. And cross multiplying, so x plus 1 whole squared into x plus 1 will become a x plus 1 whole cube, and that will be equals to 1. And that was the equation that we had to prove. Now in part 2, we have to find the exact value of d square y upon dx squared. So first finding an expression for d square y upon dx squared. So differentiating 2x into 2x plus 1 to the power 1. So this will become 2 into x plus 1 to the power 0. So that will become x plus 1 to the power 0 will be 1. And differentiating x plus 1 to the power minus 2. So minus 2 into minus 1 will become a plus 2 into x plus 1, and the power will decrease by 1. So it will become a minus 3. So the expression for dy dx will be 2 plus 2 upon x plus 1 whole cube. Now we know that x plus 1 whole cube, if we make this a subject over here, x plus 1 whole cube can be written as 1 upon 2. So substituting 1 upon 2 in place of x plus 1 whole cube, that will become 2 divided by 1 upon 2. 2 will go in the numerator, become a 4. So 2 plus 4, and that will be equals to 6. So the exact value for d square y and dx squared will be equals to 6. In part 2, we have to find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis, and we have to find all the necessary working. So the formula for volume is given by the formula integral with the limits b and a, pi multiplied by the integral of y squared. So in this question, the limit will be 1 and 0, as we can see that the shaded region is from 0 till 1. The equation of the curve is x plus 1. So that is x plus 1 whole squared plus x plus 1 to the power minus 1. And we have to whole square it in the first instance and then integrate it. So whole squaring this as, so this is x plus 1 over here. Now we can treat this as, so this is x plus 1 to the power minus 1. Now we can treat this as a plus b. So we can apply the formula a squared plus 2ab plus b squared to expand this to do the whole squared. So this will become a is x plus 1. So that will become power 4 plus 2 into x plus 1 whole squared into x plus 1 to the power minus 1. And then x plus 1 to the power minus 1 whole squared will become a power minus 2. Now, before integrating, we can simplify this. So this will become x plus 1 to the power 4 and x plus 2. This is power 2 and power minus 1. So this will become 2 into, so 2 minus 1 is 1. So this will become 2 into x plus 1 power 1, and this will remain as it is. Now integrating the expression with the limits 1 and 0. So integrating x plus 1 to the power 4, that becomes a x plus 1 to the power 5 upon 5. Plus this will become 2 into x plus 1 whole squared divided by, so that will divide by 2, the new power. And over here, when we increase the power by 1, so that will become minus 1 and will divide by minus 1. We can simplify this. So the 2 and 2 will cancel out. We can write this as x plus 1 upon 5. This is x plus 1 to the power 5 plus x plus 1 whole squared. And this will become minus 1 upon x plus 1. Now substituting the limits. So the limits were 1 and 0. So in the first instance, substituting x equals to 1, we will get 1 plus 1 to the power 5 upon 5 plus 1 plus 1 whole squared minus 1 plus 1, which is 2. And we'll subtract it from the lower limit, which is 0. So this will become 0 plus 1. So this will become 1 upon 5 plus a 0 plus 1 whole square will become a 1. And this will become minus 1 upon 1. So that will become a minus 1. So 2 to the power 5 is a 32. We'll get 32 upon 5 plus 2 squared is 4 minus 1 upon 2. And we'll subtract it from, so 1 and 1 will cancel out from 1 upon 5. Taking the LCM throughout, so we'll get the LCM as 10. So 5 will multiply by 2. So this will be 64 plus, so this is 1 up here. So this will become a 40 minus this will multiply by 5. So this will also multiply by 5. And this will multiply by 2. So this will also multiply by 2. So 64 plus 40 is 104. 104 minus 7 is 97. So we'll get 97 upon 10. And we have to add a pi to the final answer. And 97 upon 10 can be written as 9.7 pi. So the volume under the shaded region will be equals to 9.7 pi.